This video is about properties of logarithms. And before we talk about those specifically, it's good to look back at properties of exponents, which I have here in blue on the right side of the screen. And there's a few more, but these are the three main ones that come up. That when we are multiplying two things with the same base, we add the exponents. That's where we get the 5 from. Similarly, it's more or less the same rule. When we're dividing things with the same base, we subtract the exponents. And that when we have one exponent raised to another exponent, we multiply the exponents together. Those are the three main exponent properties that we have. Remember that logs are exponents. And so as it turns out, log properties actually are those same exponent properties. They're just written in a little bit different form, but we do want to see that they are in fact the same thing. Now, these are really the three log rules that we have. These are the three ones that are going to come up, and you'll see in the next couple of pages what those questions might look like, but these are the ones. The first one says that if you're taking the log of two things that are multiplied, that you can add the individual logs of those things together. Okay, what is this really saying? Well, it's saying that when you multiply two things, you add their exponents together because logs are exponents. Well, that's this rule. When you multiply two things, you add their exponents together. We have that rule already. These are the exact same rule. Just one of them is written in terms of logs and the other is written in terms of exponents. So they look very different, but they actually really say the same thing. The second rule, similarly, this rule says that when you have two things that are divided, you can subtract their logs. Well, we already have a rule that says if there's two things that are divided, you can subtract their exponents, and logs are exponents. So these two rules are the same. Then we've got this last rule that says the log of something with an exponent. Basically, the way you remember this is this exponent just kind of moves on down to the front. You can bring it down in front. Well, okay, this is saying that if you have a log of something with an exponent, you can multiply by that exponent. Let's figure out what that means. Well, we have a rule that says if you have something with an exponent, you multiply the two exponents. If you have something with an exponent, you multiply the two exponents. Again, log of A is an exponent. Logs are exponents. We're multiplying the two exponents here. So I hope that shows you that, in fact, these three log properties and these three exponent properties are actually the same thing. If you don't totally get that, it's okay. You can still memorize these three properties, and these are really the ones that are going to come up. So let's look at questions just to see what questions might look like with log properties involved. So, pardon me. This is one direction that you might get with these questions. You might get something like this, and it'll say expand. And what that means is to use the log properties kind of in this direction, to take like something that was one log and expand it into two logs or maybe more. So let's see how that would work here. Let's start with well, I guess we can start with just separating it into two pieces. We have this rule that says that if there's division, you can subtract the log of the denominator from the log of the numerator. So I could write this as the log of the numerator minus the log of the denominator. Now, I think pretty soon you'll be able to do everything that we're going to do here in a minute. You'll be able to do that all just in one step. But for now, we'll take it in a few steps. So this part's done. If we look here, we actually have the log of two things being multiplied, the log of 3 times x squared. So we can separate those using this addition rule. Log of two things that are multiplied is you can add the two individual logs together. So we could write this as log of 3 plus log of x squared. And then we still have minus log of y over here. And now one more thing we could do is we know the exponent rule, that when you have a log of something with an exponent, that exponent can be brought down to the front. So our final answer to this would be it's 2 log x minus log y. And that would be the fully expanded version of what we started with. So let's do one more of these. You notice this one just said log, so I just had log. This is specifically log base 3, so basically we've got to do the same thing, but write log base 3 on everything. And I'm going to show you what this looks like if we do this. Well, we'll do it almost all at once. Starting with the numerator, we know that within this numerator, we're going to have that addition rule. So I'll start with log base 3 of x plus log base 3. Now, we have the radical here. I'm going to write this instead as y to the 1/2. That's going to make it easier to deal with in a minute. And then the denominator, now we're going to be subtracting. So that'll be minus log base 3 of 3. So there's a couple things that we can make just a little bit nicer in format here. One is, so that's that. Here's an exponent. We can bring that exponent down front. That's that third log rule. The other is, this is actually a number, log base 3 of 3. So what exponent would turn 3 into 3? Well, that's just 1. And this would be our final answer. So those are two examples of expanding logs using those properties. Similarly, you could have questions that give you the expanded version and ask you to condense or simplify into one log. And so same rules, we're just kind of going backwards here. So for this first one, I'm going to take an extra step because we've got these coefficients in front. And remember those, if we're kind of working backwards here, those are all going to sort of jump back up here and become powers. So I'm going to take one step and do that. So that'll be log of x squared plus log of y to the 1/3 minus log of z cubed. Okay, now we're in good shape to put this all together into one log. So positive things will be in the numerator. Anything subtracted will be in the denominator. I'll put the line in there. So positive y to the 1/3, so I'll put cube root of y. And then the denominator, z cubed. Now, there may be a question that comes up about this negative sign here. Is this negative part of the exponent? Just in case you had that question. If you didn't have that question, don't worry about it, but just in case. So let's say we moved that -3 up to the top. So we started with -3 log z. We moved that all up to the top. So we ended up with log of z to the -1/3. Well, pardon me, the -3. And that would be positive. So this would tell us, okay, we've got a z to the -3 in the numerator because we're adding. But of course, that would just turn into, if it's z to the -3, it would turn into 1 over z cubed. So it would end up in the denominator either way, just in case you had that question. And again, if not, don't worry about it. All right, one more here. And yeah, just for a little interest, I'll make it log base 6 there. Okay, so we've got, again, these coefficients that become exponents. So let's do that first. This will be log base 6 of x to the 5th minus log base 6 of y to the 4th. Same thing, that coefficient becomes an exponent. And then plus Now, what do we have here? We've got just a 2. Okay, this is interesting. So we don't have a log, right? How can we express this in terms of logs? So ultimately, we're going to need an answer that's log base 6 of something, right? So we need to find a way to write 2 as log base 6 of something. Well, let's see what that means. Log base 6 of something equals 2. So we could put this in exponent form, but I think we could see what's going on here. This is saying that 6 to the 2 equals something. Well, we know that 6 to the 2 equals 36. And so what we actually need here is 36. And if we want to go back and check log base 6 of 36, so 6 to some power is 36, that's 2. Yeah, these are actually equivalent statements. So we're in good shape there. And now that we have everything in terms of log base 6, now we can combine everything into one log. So log base 6. Numerator, we've got x to the 5th. And let's see, that's a minus. So that's denominator y to the 4th. Oh, and then we actually have, this is going to be numerator. I'll move this over to make the format a little better. So we'd have x to the 5th from here, and then we'd have a 36 right there. So those are some good example questions with log properties. Again, there's really just 3 that are important to know, that they're the same as the corresponding exponent properties. And that the 2 main kinds of questions that you get with this are either expanding from one log into several logs, or simplifying or condensing from several logs into a single log, all in one piece.